Hello and welcome to the first tutorial of EC2151 Electric Circuits and Electron Devices Basics. The first term we are going to see is current. Current is defined as the flow of electric charge carried by movement of electrons, and it is denoted by the letter capital I, derived from French phrase intensity current, or in English we call it as current intensity. The unit of current is ampere, named after French physicist and mathematician André-Marie Ampère. Direction of current. The direction of current is a little bit a complicated topic. When we say the direction of current has a positive value, it means that the actual direction of the current through the circuit element is same as that of chosen reference direction. It depends on the direction of reference, depends on the point of the reference. If we say the current has a negative value, that means the actual direction of current through the circuit or through that circuit element is opposite of the chosen reference direction. Generally, the actual direction of current through a specific circuit element is usually unknown. So let me consider this as my reference point A, right? So this is my reference point A. So when hooking up the circuit, the current starts from here, goes there, and then goes to the bulb, and then reaches the point A, after which it goes to the battery pack, right? So I will say this is having a positive value, right? So if I consider here, let's say this is the point A, the same circuit where I have altered only the batteries, right? So here the current flows like this, and it leaves the point A, goes to the bulb, and then it reaches its negative, right? So here I will term the current as a negative value, right? So here the current goes through the positive and then goes here. So I'll just mark an arrow mark here, right? The current goes through the positive and reaches here. Here the current leaves the reference node A. The current leaves the reference node A. So I will term this current is has a negative value, right? So it once again depends upon the designer. Types of current. There are two types of current. One is called direct current and another one is called alternating current. Direct current, that means the direction of the current does not change with respect to time. The example of the direct currents, the sources for direct currents are our batteries, which we use in our daily life. The pen torch battery, this is the camcorder battery, or you can say it's a mobile battery. Those are the sources of direct current. This is the symbol of this is a symbol to denote the direct current, right? So what do we mean by, if we draw a graph, right, for a direct current with respect to time t, right, the output will be always positive or the output will be always negative, and it does not change with respect to time, right? So if we consider time here, it will be either positive, it will be either in the positive direction or it will be in the negative direction. So that's all about the direct current. And alternating current. Alternating current, the direction changes periodically. The source of our alternating current is our own household, our what we see in our regular life, the household plugs or sockets, right? So if we draw a graph with the types of current, we will have a signal that varies positive for some time and negative for another time, right? So this is with respect to t. So in India we say it as 230 volts and 50 hertz, which is very much important. You need to remember this, and which means the direction will change on 1/50th of the second. That is, every 20 millisecond the flow of current will, the direction of the current will varies, or like no, it's actually not 20 millisecond. For every 20 millisecond will have a positive and a negative cycle, right? So this will be 20 millisecond, right? So for 10 millisecond we will have a positive cycle, and for the next 10 millisecond we will have a negative cycle. So this duration will be 10 millisecond, and this duration, the negative duration, will be 10 millisecond in India. This is for India, right? So let me go through you once again. There are two types of current. One is direct current, another one is alternating current. The direction of the current that does not change with respect to time is known to be direct current, and either it will be positive for the whole life or it will be negative for the whole life. And alternating current, the source of alternating current is our own household sockets, plugs and sockets. And in India we have it as, for every 20 millisecond we will have each cycle, and each cycle consists of a positive value and a negative value, which means for the first 10 milliseconds we will have a positive value, and for the next 10 milliseconds we will have a negative value, right? So the next term you need to know is voltage. Voltage is referred as a electrical potential difference between 2 points. The unit of voltage is volts, and it is denoted as joules per coulomb, right? So the term joule denotes the energy. It's generally the energy accumulated at one point reference to another point, right? So let's say here we have our circuit diagram. So we have two battery cells which has 5 volts, right? So this is also a 5-volt battery. So we will be having here a positive 5 volt, and this point also we will have a positive 5 volt, right? So let's say this is our reference point, right? Reference point A. So the same positive 5 volt will be here, and at this point, right, what is the potential difference? You need to calculate the potential difference. Potential difference is the difference between the charge accumulated on a point with respect to the reference point A. So here we have positive 5 volts, and here we also have positive 5 volts. The same point is given here, right? So it's short circuited. So the difference between positive 5 plus 5, right? The difference between plus 5 minus plus 5, right? So this will lead to an answer of 0. So the potential difference is 0, which means the energy is 0 at this point, so the lamp will not glow, right? So if we consider this area, here we have positive 5 volt, right? Sorry, right? So here we have a positive 5 volt, right? So at this point we will have a positive 5 volt, right? And this will be a 5 volts, so it is connected to the negative, so we will be having a negative 5 volt, right? Negative 5 volt. So let's say this is a point A, this is our reference point. So if we consider this point with reference to our reference point A, then we will have an energy that is the difference between the voltage accumulated here minus the voltage accumulated here. So it will be plus 5 minus 5, right? So this plus 5, this plus 5, and this minus is this, which is in the voltage accumulated at this point, so which is equal to 10 volts. So the energy given to the bulb is more here rather than the previous circuit. Previously we gave only a 5 volt circuit, now we are giving a 10 volt, which means we are giving more energy, so there will be a more illumination from the bulb. The next is the resistance. The electrical resistance of a electrical conductor is the opposition of the passage of the electric current through the conductor. Simply, it is the opposing property of a conductor to allow a electron, right? All materials will have some resistance, either it's a copper or it's a wood, whatever it may be, there will be some resistance, and only for superconductors we are considering the resistance as 0, right? The unit of resistance is ohms, and for copper there will be a 0.02 ohms of resistance, and for a wooden piece we have 1 mega ohms of resistance, right? The next term is power. Power is considered as a rate at which electrical energy is transferred by an electric circuit, right? So the unit is watts, and what you need to consider is the energy per second, joules per second. The energy that is being converted into a form per second is considered to be the power, right? So it is being calculated as I into V, or I square R, or V square R. I into V is current into voltage. Coming to the very important term of our study is called Ohm's law, right? The Ohm's law states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points, right? So V is directly proportional to I, right? So introducing the constant of proportionality, the resistance, if we are introducing the resistance as a constant, then V is denoted by I into R, which is a very important formula throughout your study, because using these formulas, we will be using only this formula, we will be calculating voltages and current, and we will be solving the circuits. So let's see a circuit, a simple circuit. Let's say we have a voltage of 5 volts here, right? And let's say the resistance of the bulb is around 200 ohms. This is an example, around 200 ohms, right? So then the current I equals V divided by R, which is equal to 5 divided by 200 amperes, right? So this is how we calculate the current consumed by the bulb by knowing its voltage and resistance. Thank you for watching.